Hello everybody. In this video, we will be discussing about using a second order low pass filter using Texas Instruments op-amp TL082. We will be building the filter using a unity gain amplifier, that is a voltage buffer in loop with another unity gain amplifier. Let us have a quick look at the circuit that is used. To implement the circuit, we are using Texas Instruments Analog System Lab Starter Kit. After we implement the circuit on the ASLK starter kit, the circuit looks something like this. Now, the external connections for the measurements are made as shown. Sinusoidal signal of suitable magnitude is used as input. The frequency is varied ranging from 1 kHz to 1 MHz, and the value of the output voltage is measured on the CRO. For each value of the input frequency, the peak-to-peak value of the output signal is measured on the CRO and is noted down. Also, for the same reading, the time difference delta t is measured in order to calculate the phase difference. Using these values, the frequency response is plotted. We see that the phase does not change till the frequency reaches 40 kHz. After this stage, the increase in phase difference is very significant as it appears. Now, as we go on increasing the frequency beyond 50 kHz, there is peaking in the gain plot and a roll-off in the gain after 200 kHz. From the plot, it is clear that the minus 3 dB point, that is the cutoff frequency, is near 283 kHz. After the cutoff frequency, the output rapidly decreases, thus functioning like a second order low pass filter. Lastly, a square wave of 1 volt peak and 100 Hz is applied as an input to the setup, and the transient response is studied on the oscilloscope. The basic challenge for us was to understand the basic principle of the given circuit, so accordingly we had to study the basic working of op-amp and its parameters. We also had to study the filtering effect of the circuit. Now comes the simulation part. We faced greater challenge in finding a suitable software for our use because many available demo versions lacked some necessary features. However, we then found TI software and we could successfully simulate our circuit. In the practical implementation, we faced some difficulties in managing our time slots because the given kit had to be shared between the teams. Also, finding out the phase difference through the readings of the CRO was initially thought to be difficult. Finding out the transient response was also some task. We got to learn a lot through the phase 1 of TI ADC. One of the main things that we learned was to make a filter circuit without inductors and capacitors. We thus gained a deep knowledge of second order op-amp filters and also their various parameters. We learned about the frequency and transient responses and their interpretation.